Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now video for Course 1 CP for Friday, May 15th, 2020. So in this video, we're going to cap off the week with a little bit of extra practice on converting to standard form and intercept form using the box method. If you haven't taken a look at my 4 videos, actually 5 videos on those conversions, maybe even 6, I recommend you take a look at the class Google Doc for more info on that. So remember, in the end, we want this first one to look something like these two. This is standard form. And then in the last one, for when we convert to intercept form, remember converting to intercept form means it should look something, and I apologize, my thing's a little bit delayed there. It should look something when we go to intercept form, okay, like this. This is the intercept form. Alright guys, so again, please pause the video, convert the first to standard form, these two to intercept form, then when you're ready, unpause, and you can see what I got. Alright, here we go. So to convert to standard form, the first thing we want to do, in this case, because we're currently in vertex form, is to build ourselves a nice little box. Okay, on the top, we're going to put p minus 1. And on the left, we'll put p minus 1. And then we have p squared minus 1p, or just minus p plus 1. In this case, because a is not 1, I'll drop my a value in there. P squared minus 2p plus 1. The next thing I want to be doing here, given this 3, is I want to be boop, 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 distributing there. And when I do that, what I'm going to get is 3p squared minus 6p plus 3. And then the last step is to combine. So 3p squared minus 6p minus 3. Alright, so that's how you do that one. So again, we're following the PEMDAS here. So I'm first doing the exponent, which means I'm doing p minus 1 times p minus 1. Then I'm doing multiplication. And then I'm doing subtraction, just like I would do with PEMDAS. Okay, moving on down. Now I've got to convert this to intercept, or what we call factored form. And this is using the box, but going in the opposite direction. So remember, there's a couple important patterns that we talked about here that when I build my box, I'm going to want to remember. Okay, the first is that the squared thing will always go in the top left, and just the number will go in the bottom right. Okay, the reason is we know that only one of these is going to contain t. Okay, so if this needs to have a t in it, okay, so if this contained a t, or if this contained a t, then this 48 would have to contain a t, but we know 48 does not. So that's how we know that the top up here and the bottom down here are going to be just numbers. Now, how can I multiply two numbers and get 48? So I could have 1 and 48, I could have 2 and 24, I could have 3 and 16, I could have 4 and 12, I could have 6 and 8, and that is all. So I take a look through. Any of these look promising? Looks like 4 and 12 does, because 4 plus 12 equals 16. Let's try it out. So I'll just choose to put 4 up here, plus 4 plus 12, and let's check it out. I do t in 4, I get 4t. I do t in 12, I get 12t. I add these up for my 16t. So this is good, and the final answer I report is t plus 4, t plus 12. All right, so think about that strategy. Last one here. Very similar. So I'm going to set up my box. Okay, up in the top left, we're going to put our squared. On the bottom right, we're going to put our number only. Okay, so then remember, up in the top, we're going to have a J. Up on the left, we'll put a J. So J times J is J squared. And now remember, our goal is to multiply to 22. The good news is 22 is pretty simple. It's more or less 1 in 22 and 2 in 11. What makes it challenging is that this is a negative number. And so remember, the only way to multiply two numbers and get a negative is that one is negative and the other is positive. So we need to make sure that not only do we multiply to this negative 22, but when we add, right, we're going to get the negative 9 from these two boxes. So to do that, I'm going to make this negative 11 and this positive 2. The one thing to remember whenever you do this is that every wrong answer is okay, because a wrong answer gives you insight. For example, let's say I had done it the other way. Let's say that I had said, oh, well, you know, to me it makes sense. Negative 2 times 11 does equal negative 22. If I had done that, what I would have gotten is positive 9j instead of negative 9j. And what that would have told me is, hey, wait, Mr. Moray, you just have your signs flipped. And once I flip my signs back to positive 2 and negative 11, then this becomes negative 11j, and this becomes positive 2j, and now it works. So don't worry if you don't get it right on the first try. And that's part of the reason that I'm teaching you this way. It's because I want you to play around with the numbers. I want you to find the patterns. I want you to take those chances and make mistakes. It's an important opportunity to do that, and it's about getting comfortable with a strategy that can help you in many different ways, this box idea. All right, so hopefully you're able to get this right. If so, congratulations. In any case, welcome to the end of another week of math here at Milton High School. Thanks for continuing to tune in. I'm looking forward to another great week of math next week. Have a wonderful weekend, and I'll see you on Monday.